Hi everyone. I wanted to show you a couple examples from our symmetry, our even or odd functions, or our piecewise functions homework because sometimes graphing this kind of stuff can be a little bit tricky. So I'm going to show you the steps that you should take so that when you're doing this, you're not trying to pull your hair out. Okay, so first things first, I want us to all see that we have a piecewise function here with three equations. So our first equation is that y is equal to 2, and we know that this is a case only where x is less than or equal to negative 2. So when I think about that equation, y is equal to 2, that means I can have any two ordered pairs so long as y is 2, right? Because we know it's a horizontal line. So I'm going to go ahead and use the following ordered pairs. So I'm going to use my boundary point of negative 2, so negative 2, 2, and then it has to be an x value less than negative 2, so we'll go negative 3, positive 2. Okay, with that in mind, we're going to go ahead and grab our line tool here. And that's because it's going to continue on towards infinity less than negative 2. So I'm going to grab my line tool and I'm going to plot the point negative 2, 2, which is right here. And then I'm going to plot the point negative 3, 2, which is right here. Beautiful. Now that I have my line, I look at the boundary point and I see, oh, this is x is less than or equal to negative 2. That must mean that my boundary point is closed. So now grab your closed circle and place it on the end here. And that's your first line. Okay, let's now take a look at the second equation, which is y is equal to x minus 1. This time we have a region, right, which is negative 2 to positive 2. So when we actually go ahead and graph this, we want those boundary points so that we know exactly where it ends on this graph. Okay, to make this happen, we're going to say, well, if I plug in a negative 2, what's my output? So that means we have negative 2 minus 1. So I'm just going to write the math here. So we have y is equal to negative 2 minus 1, which is going to give us a negative 3. So my first point is negative 2, negative 3. I do want to point out that it's an open circle at this endpoint because it's less than. So I'm going to write open just so that I can remind myself that that endpoint is an open circle. So next I have to find the other boundary point, which is at 2. So I'm going to say, all right, when x is 2, what's y? So we have y is equal to 2 minus 1, easy, that's a 1. So my other boundary point is 2 comma 1, and we know that because this is less than or equal to, it has to be closed. So this is a line segment. It's not continuing towards infinity. With that being said, we're going to grab our line segment tool and we're going to plot the point negative 2, negative 3 very carefully, and then 2 comma 1. Perfect. I have an open circle at this left end point. There it is. Oh, let's drag it. That's a cool thing. We can actually pick it up and drag it. And then I have a closed circle at 2, 1. Let's go ahead and place that here. Perfect. Okay, I'm ready to work on the last equation, and that is y is equal to negative x minus 1. This is only when x is greater than 2. So same exact idea, I'm actually going to input that boundary point of 2 so that I know where I'm beginning, and then I'll continue from there. So when x is 2, notice that this is going to give me negative 2 minus 1, which is equal to negative 3. So we can plot the point to negative 3. Keep in mind, this is greater than, which must mean it's an open circle. So I will start at, and remember, you're going to use a line tool that goes towards infinity because there's no end point. It's all values for x greater than 2, so it must go towards infinity. So let's grab our line tool. We're going to start at the point 2, negative 3. So we have 2, negative 3, which is down here. And then I'm going to apply the slope. My slope is negative 1, right? It's this coefficient here. So negative 1 is my slope. So I'm going to go down 1 over 1 and plot that point. Again, we saw that it was an open circle at the endpoint on the boundary. So I'm going to take my open circle, place that here, and then I'm going to submit my answer. And that will be correct. Okay. Perfect. Let's do the same thing, but this time we're going to check out what happens when we have a non-linear function that we are graphing. So I'm clearing all of this stuff. There's my function. It looks perfect. So let's go ahead and check out this guy. Okay, we have our two equations. First, y is equal to x, and that's when x is less than -3. I have a boundary point here, so I'm going to plug in that value. So when x is -3, well, y is a -3. Because this is less than, we know that's going to be an open circle on that boundary point. So I'm going to take my line tool, and we're going to start at the point -3, -3. Perfect. Now keep in mind, my slope, y is equal to 1x, my slope is positive, so it's up 1 over 1. However, if I graphed that point, I'm literally going beyond my boundary line. I have to stay to the left of it. So instead of going up 1 over 1, I'm simply just going to reverse it. And this line still has positive slope, and specifically, it has a slope of 1. At that endpoint, we said it was an open circle, so we're going to go ahead and plot that open circle right there. Next, our second equation, our nonlinear equation, is y is equal to the square root of x plus 3. And this is when x is greater than or equal to -3. I'm going to go through the same process. Let's plug in the -3 value here. So if we have y is equal to the square root of -3 plus 3, this is going to give me y is equal to the square root of 0, which is just 0. So my first point is a -3. That was what I inputted, comma 0. This is going to be a closed endpoint. Now, notice here with this square root tool, you need a second point. So what I like to think about is if I'm taking the square root of something and I want to actually graph it, I want to have a perfect value. So square root of 3 won't work. Square root of 4 will work. So if square root of 4 will work, then that means my x should be a 1, right? So let's test this out. So if x is equal to 1, so we're looking at x comma y. Actually, I don't need that. I'm going to erase this. I need to write this out. We want x to be 1. If we plug in a 1 here, we have y is equal to the square root of 1 plus 3, which is the square root of 4, and we know the square root of 4 is 2. So now we have our second point, which is 1 comma 2. Okay, let's go ahead and grab our square root tool. We're going to start at the boundary point, which is -3, 0. So -3, 0 is here on the x-axis. My second point is going to be 1 comma 2. So 1 comma 2 is here. And then, of course, as we mentioned earlier, the boundary point is closed. So let's grab the closed circle and place that right on top of that point there. And that is your final answer. Okay, I hope that that is helpful in terms of breaking this down and going piece by piece. These were the more complicated ones. So follow this video. Hopefully it helps you to get this correct. All right, everyone. I will see you on Monday. Bye.